Hey YouTube, welcome to the next installment of the Avion blog. So today we're going to do a bit of a basic tutorial on component testing, electronics repair testing basically. What we're going to do is take a couple of components. I'm going to show you guys how you can test them to see if the components are good or not. And we're also going to go through a basic switch mode power supply board and actually just show you guys how to test various components for faults and see if you can pick up any issues. Electronics repair basically relies on diagnosis, and basically what we're doing with this tutorial is showing you guys the practicality and the usefulness of a standard digital multimeter in fault diagnosis. In fact, 99% of the faults in electronics are discovered and diagnosed with nothing more than a simple digital multimeter or even an analog multimeter. So let's get into that and see what it's all about. So, how do you measure components? The basic way in the electronics industry for testing and measuring components is using something called a multimeter. So what we're going to do today is we're going to go through a few basics of using a multimeter to test various components. And of course recognizing components, etc., what they are, what they're used for, etc. Google's made it a lot easier nowadays with actually being able to do this sort of work, as you can always just Google the reference of a component and you'll find out straight away what component it is, what its specs are, and of course pretty much just about everything you want to know about it. So let's get into testing the basics of components: resistors, inductors, capacitors, transistors, diodes, maybe a couple of MOSFETs, and see what it's all about. Okay, starting at the absolute beginning, we've got these little guys over here, which are commonly known as resistors. Let me just see if we can adjust the exposure on this so we can actually see it. As you can see, there's our little resistor. This one, the color code is brown, black, orange. So to be able to calculate the color code of this resistor, or the value of this resistor, we take that the gold stripe is basically the tolerance, but we just want to know roughly what the value is. So brown, black, orange. Basically we go with the color code. It's quite a simple color code: black, brown, red, orange, yellow, green, blue, violet, gray, white. So okay, brown, black, orange. Okay, so black is 0, brown is 1. Okay, so we got 1. Black being 0, 1, 0, and then orange is black, brown, red, orange. So it's 1, 0, 0, 0, 0. So it's a 10K resistor. So basically, if you head over to your resistance and you do a test on the resistor, it should read around 10K. So as you can see, 9.85K, 9.86K. So it's more or less within the 5% tolerance of the gold stripe. That's the basis of testing resistors. Resistors are used in electronics as voltage divider circuits and various other things, but they're very common. In fact, very few electronics projects or electronics designs will actually not have resistors in. So get used to resistors, get used to the color code: the black, brown, red, orange, yellow, green, blue, violet, gray, white, how to use it. Of course, SMDs make things a little bit different, but the basis is still the same for testing them. Next, we're going to take a look at diodes. Diodes, again, let's just see if we can get a focus lock on this. Just drop the exposure down. I'll basically think of them as a one-way wire. It's an NP junction or a PN junction, whichever way you'd like to look at it. Anode and cathode, you've got a little white line. Basically placing a positive lead on here, negative lead on here, you'll get a 0.5 to 0.7 volt drop through the diode, but it will allow power to flow through it one way but not the other way. So how do you test that now with a multimeter? It's actually pretty simple. Multimeters have made working with these things much easier. You have something here called the diode test. You head over to that diode test. If you check it in reverse, as in the positive with the white line side and the negative lead on the other side, you will get nothing. If you read something here, generally the diode is faulty. If you reverse it, where you've got the positive pushing a current through towards the white side, then you will get your 0.5 to 0.7 volt drop. As you can see, 0.553 volt drop across this diode. So we know from that this diode is good. Now, while on the topic of NP-PN junctions, we're going to have a look at something called a transistor. This is a tip 41C. You've probably seen these inside your electronics. Basically, this is a NPN transistor. It's made up of the same stuff that is used to make up diodes. So basically it's got 2 diode junctions inside it. So the way to test that, being an NPN transistor, the base collector emitter. So base to collector in reverse, you'll get nothing. Base to emitter in reverse, you'll get nothing. But then again, if you reverse that and you put your power onto your base to collector, there's your 0.605 volts drop, base to emitter, you got your 0.608 volts drop. So from that you can more or less ascertain that the transistor is working. As you can see, we have no other cases where we have conduction or anything like that. So okay, there we go, tip 41C working. Now if this was a PNP transistor, you would do this in reverse. So basically you would get readings from the negative being on the base and the positive being on the other two, and no readings the other way around. So it's basically an exact swap around of the NPN transistor. Now the next thing we're going to have a look at is a resistor. We've actually looked at resistors. We're going to look at a capacitor. Now multimeters are not really great for testing capacitors. This is a 10 microfarad electrolytic capacitor. But what we're going to do now is we're just going to check the value of this capacitor using the multimeter, just to get an idea if it's good or not. 10 microfarad cap reading at 9.27 microfarads. So yeah, it looks alright. But is this capacitor really okay? The simple way of finding a capacitor and checking if it is actually functioning the way it should be is using something called an ESR meter. Now ESR meters are not built into multimeters. They are relatively available, but just to get a guideline if the capacitor is alright, this can help you out just to check the value, measure the capacitor, see if it's good or not. Obviously the ESR meter will tell you 100% if the capacitor is good or not, but besides that there's not much else. Now there's many more components that we can have a look at, but some of them that interest me the most are some things called MOSFETs. Basically the diodes and the transistor testing can be carried through with most semiconductors except for MOSFETs. MOSFETs are a little bit different, so what I'm going to do is I'm going to show you guys an N-type MOSFET, which is basically the equivalent of what would be an NPN transistor, or a P-type MOSFET would be a PNP transistor, but I'm going to show you guys an N-type MOSFET and how to test it using a normal multimeter. So let's get into that. Right, here we have our common N-channel MOSFET. Gate, drain and source. So if you put your positive in your drain and your negative in your source, you'll see the transistor is currently switched off and climbing. There might be some static in there, basically turning it on a little bit. There you go. So basically this MOSFET is off. But now if I move this positive lead and just temporarily charge the gate, then this MOSFET will switch on, basically contacting between these two terminals. So I'm going to do that, on, and come back here. As you can see, we've got 0 volts drop, so basically the MOSFET is turned on. If I was to touch that just to discharge it and come back, as you can see it's climbing back up to infinity again, or overload. To turn it on, touch, come back, and it's currently switched on. It's a simple way of testing a standard N-type MOSFET. It does the job of letting you know if the MOSFET's good or not. But yeah, the simplest way to check them is just to check them, and if you find there are dead shorts and stuff like that, then generally the MOSFET is bad. But that is the more accepted way of testing a MOSFET out of circuit, just to check if the MOSFET is good or not. And yeah, there's a lot more we can go into on this. So variable resistors and the likes, maybe we'll do a few of those. Let's do that so you guys can see how to check if your little variable resistor is working. It's quite simple. Again, we're going over to the resistance scale. This variable resistor should be 100k, so we should see 100k from end to end. 84.6k. Now between any of these points and the center wiper will be adjustable. So basically as you sweep through, the resistance will change. And it's a simple way of checking if these little variable resistors are working or not. Now these are little presets. They normally soldered to board and used to preset resistance values or to make adjustments to circuits after construction where maybe you didn't have the exact calculation or you need to bias something properly. These are generally used. You get a bigger type of variable resistor called a potentiometer, which is used in volume control applications and the like. Now, one more thing to quickly check, switches. How do you tell if the switch is working or not? The simplest way is continuity mode. Go across the switch, activate the button. If when you activate the button you're getting continuity, obviously your switch is working. Simple, easy to understand, and it's electronics, guys. It really is a simple thing to learn the basics of. So in circuit testing, a little bit different, because you must bear in mind, for example, you may have resistors on their own, or you may have resistors in series, resistors in parallel, capacitors in series, parallel, which would change the values when you measure them. In series, not so much of a problem, but let's say you have two 10 ohm resistors in parallel and you're trying to measure it, you're going to measure 5 ohms. So it's kind of a bit of a tricky mess, but you can still get an indication if things are working. I mean, if a resistor's gone closed, you're going to get a dead short. If it's opened, you're not going to get any resistance. But you can go through it on your resistance scale. 500 ohms there. Here's a Zener diode, so we can go across to the diode test. Check it in forward. Nothing in reverse. Check it in forward. And we have 0.6. Obviously there's some capacitors charging over there. 0.66 volts volt drop, so that looks good. Again in reverse, it'll climb up to nothing, so okay, that looks good. If you want to check things such as inductors, you can't really check the impedance of the inductor, but you can check the throughput of the inductor. Like for instance here we've got two filter inductors, so what we can do is we can just check the resistance from one point to the other point and see. Okay, 0.5 ohms, 0.6 ohms, everything looks good there. 0.5 to 0.6 ohms. Yep, good, okay, so the inductors over there, or the chokes, whatever you like to call them, are 100% working. Bridge rectifier is basically a combination of diodes. So what we can do, we've got AC coming in here. So if we go from point A, combination of diodes, should go 0.6. Nothing. Okay, so from there to there 0.6, from there to there 0.6, other way around, nothing, nothing. Okay, then if you go there you'll have 0.6 and there you'll have 0.6, the other way around, nothing, nothing. So bridge rectifier is good. Again with the diodes, stay in the diode test mode. We got one down here. Let's go in the forward. We should see about 0.6. Forward, sorry I couldn't see the line. 0.5, fine. In reverse we should get overload, and we have overload. Happy days, so that diode's fine. And basically reverse, forward, looks good, forward, reverse. Oh, there's some resistance in circuit there, that looks fine to me. Reverse, forward. Okay, Zener diodes sometimes are a little bit different, but you're getting the gist of it. You can go through every single component on this board almost and actually test if it's doing what it should be doing. You've got a MOSFET here. You could test it in similar principles. You've got a dual diode here, dual diode over here. Dual diode meaning, flip it over, find your 3 points, diode test mode, one way, worry about the capacitors, 0.3, 0.3, the other way around. It'll eventually run up to infinity and it's all overload, obviously with the capacitors charging up, so those are good. I hope you're getting the gist of how this actually works. Some more of the little things you may find is such as a fuse here. You could check it on continuity or ohms. Okay, fuse is good, happy days. There's another little guy over there. I've already tested it, it's good. And yeah, simple way to go through and test the components on the board. Capacitors, a little bit more tricky, but I'll try and do a few just to show you guys the basics thereof, and hopefully you guys can pick it up from there. Okay, so as for capacitors, these two over here, we're going to check them. They are in parallel, which means their capacitances add up. These are 470 microfarads, so we're expecting just under 1,000 microfarads across the two. So if we head down to the bottom of the board, we've got them here. We're in capacitor test mode, and we hit it. It's telling me discharge. You should always discharge your capacitors. Just short them out because they haven't actually been powered on, so it's just residual charge buildup. Get onto them. We're showing 2,620 microfarads, or 2,600 microfarads. So actually, if you go a little bit further back, you'll find there's another capacitor here, also 470 microfarads, and yet another capacitor over there. So in effect all these capacitors are actually adding together giving you the higher reading. But if you do the math, you can actually calculate it and find out if there are enough capacitance within that area of the circuit. And this big guy over here is 450 volt, maybe around 100 microfarads. Let's check it out. Again, making sure to short it out, that there's no high potentials that are going to damage your meter or anything like that. You get on there, measure. We've got 127 microfarads, so I think it's got enough capacitance to get the job done. So yeah, as far as I'm concerned, everything looks good on this board right now. We know we're missing the 2 MOSFETs from this board over here from one of my previous videos, but everything else looks fine. In fact, if you were to power up this power supply, which I'm going to do right now, we're going to apply some power so it's hot and do the traditional measurements of volts. So on the big capacitor, we're expecting our volts DC around 300 volts, so let's get in there. We got 314 volts of DC. It's quite a lot of energy sitting over there. That's why I always say be careful of those capacitors. So the bridge rectifier capacitor is doing its job, and we're expecting a standby 5 volts on these points over here. And then we've got our 5,137 volts, so we know the switch mode is working. The standby voltage is working. The flyback section over here is not working, but the actual DC power supply section is working fine. All diagnosed using nothing more than a multimeter. In fact, this power supply, even finding these 2 dead MOSFETs over here, multimeter did all the work. The only time I used an ESR meter was to test these 3 caps here, well, to test all these caps, which we subsequently replaced these 3 because the ESR was showing a bit high. But besides that, everything else was tested with nothing more than a multimeter. But in so saying, you could have probably very easily have figured out that these 3 caps were gone because they were all swollen. So much of a much. So yeah, there we go. Basics of electronic multimeter use for a repair scenario. Thanks for watching. Just while we're on the topic, I've just cut back to the camera. This power supply has been unplugged for about 4 minutes already. It's out of interest to see how much is still sitting on this capacitor. Has it discharged? Almost. 11. Looks like it's discharged and it's going back up. What we can do is we can do the low impedance and completely discharge this capacitor. Go back to DC. We've got 0.6 volts. It's going to climb up a little bit, which is fine. But board is now safe to touch, safe to work on, safe to pick up. You're not going to get any nasties. So simple repair diagnosis. Switch mode power supply is one of the more dangerous objects to work on if you're not familiar with electronics, purely because of this high DC potentials over here and the high voltages. Pretty much this whole area here contains between 230 and 300 volts, so you don't want to be toying around here. The outside here, not so bad. This side here, very dangerous again, because you've got your 2 big backlight inverter transformers. Well, they're not big, but put out quite a nasty volt, and you've got your control circuitry. In fact, there you go. You've got 2 little danger stickers down there. Should tell you enough to be cautious. So don't toy around with these things unless you have an understanding and some basic safety principles, guys. People have received nasty shocks from this sort of equipment in the past. It's just not worth it. Again, thanks for watching, everyone. Take care. Have a great weekend.